Okay, here are your solutions for your Chapter 7 summative assessment on Schoology. And the first question that comes up here for me is the Test 1, Test 2 question, and they're talking about the two regression lines, which the first one is the backwards one, and the second one is your standard, where it's going to be y equals a function of x. So just keep in mind, it's very confusing the way this is presented, needlessly confusing in the IB course. The first regression line, if I can get my newfangled pen up here and running, just bear with me. IB is referring to this x as a function of y equation, but I think the sensible way of thinking about it is they want you to input the test 2 data to predict the test 1. So I'm just thinking of this as a function where I get to figure out what test 1 is by using test 2. So it's going to be a multiplied by test 2 info data plus b. Now, of course, when you go to your TI Inspire, this is y and this is x, and I can see why you would be confused because it says completely the opposite in the table, and that's just because IB wants to use a reflected version of this backwards regression equation. So as you can see, these first two spaces here, so that both lines of best fit go through the same point of averages. And I think we'll deal with that early on as well. If you do this backwards x equals function of y business, both lines will go through x bar and y bar. And of course, I'm referring to the, I shouldn't say of course, it's probably not really that obvious. I'm referring to the x and the y that's labeled in the table of values. Okay, so let's go have a look and get rid of that blotch. Let's go have a look at our calculator, type the data in, and run a regression. And just keep in mind, a moment of sanity, I want to make sure test 2 is x, and I use that to predict test 1. Okay, so here I guess I am in the TI Inspire, and I already have my data typed in. And of course, you would take some time to double check your data entry. And we'll go to a calculator, a screen here, or window, and we'll run our stats regression. It's under stats, stat calc, and linear regression. Let's go mx plus b, and then say to yourself, what am I trying to predict? Oh yeah, I'm using test 2 data to predict test 1 data. And I will store that. I think I already ran a regression earlier there, but I'll overwrite that and store that. And I guess the more typical F1, it makes no difference. But here's our regression equation. Now, a normal person would say, and your TI is actually saying this, that this is y equals 1.31 x minus or plus a minus 10.6 is the y-intercept. Now, IB wants you to reverse your variables, so both of these straight lines will go through the ordered pair, and while we're here, we might as well do this as well, where I'm going to say the mean, and x was test 1, at least in the table, sorry, not text, test 1, it didn't turn boldface type, so I knew I had a typo there. This is the x bar labeled in the table, test 1 data, and I should probably put that in decimal form, so I'll just go control enter. So there's my point of averages is approximately 28.4. I think I'll just reuse that and change that to test 2. And I think I'll just sneak in a division by 1 decimal so I don't have to tinker around with that equals. I guess I could just go control enter again. But there's the y bar. So if you use the weird IB notion that this regression equation that we have here with the slope of 1.31, if you call that a function of y, both of these straight lines will go through the point 28.4 and 29.7 approximately. Okay, so there's that question entered. We got P is 28.4, which remember that is X bar, this, which maybe I should just say is the test 1 average first and the test 2 average second. Now, unless you swap these variables, that regression equation as entered in your TI Inspire will go through 29.7 first, and then the y value will be 28.4. So just say to yourself, okay, I got my regression, and if IB asks me for what point both regression lines go through, use their x bar first and their y bar second. And now we come down here, and they actually want us to type in the slope and the y-intercept of the regression equation we already ran on our TI Inspire. So that was 1.31 and negative 10.6. We have one more where I hope we're using the same regression equation. We don't have to switch because that would be confusing. We have Jennifer who scored 28 on the second test. sorry, she was absent for the first test. Yeah, I did read that correct. And she scored 28 on the second test. Use an appropriate regression equation to estimate Jennifer's mark on the first test. So we want to use her second test score to predict her first, which is precisely what we have set up here. If I can drag this where I can read it, right about there. This was the regression that we ran earlier. I don't need this anymore, where I want to use her second test score to predict her first. So I just go to my TI Inspire. I think I'll shut this off again and just type in 28, and keep in mind it's probably worthwhile mentioning that we are interpolating here, that if we're using the test 2, that score falls well within the values in our data already, and we're not extrapolating. So let's go to our TI Inspire and figure out what Jennifer well, at least potentially would have scored on her first test, knowing that she has 28 on the second. And I think the easiest way of doing that is just use our existing regression equation. You don't have to go to the graphing window. I can just evaluate the regression equation at 28, and Jennifer would have scored, at least statistically would have scored, about 26.2 on the first test score. Okay, so we'll type in 26.2, and that is it for the first question. On to the second, thankfully of 2, where we have some puzzle pieces in front of us, and Jill is doing a 1,000-piece jigsaw puzzle, and she's sorting edge pieces from interiors. Of course, the edge has the flat side on it, and 6 times she stopped and did a count of pieces, and you got 1, 2, 3, 4, 5, 6 ordered pairs containing that information there. And Jill models the relationship between these variables. Thankfully, this is the standard y equals ax plus b, so we just have to make sure we're using edge pieces to predict the number of interior pieces she would have sorted. And we just need to enter that slope and y-intercept. I guess we might as well figure out the rest of these questions, or what's being asked of us. We just have to record our correlation coefficient, little r, and then part C is actually quite tricky. We'll come back to that one separately. So let's get the easy marks first. We'll run our regression, and I'll input the slope and y-intercept of our y as a function of x regression equation, and also, of course, write down our correlation coefficient. Okay, so here we are. I have my edge piece data and my interior piece totals, I guess, and I just stuck them over in E and F to hide them from you previously. But here they are. So we're going to use edge pieces to predict interior. So we'll go back to our calculator screen, and edge is my x variable. Of course, I need to be in the stats menu here. I want to use edge pieces to predict the number of interior pieces. And I guess I'll store that in F2 so I think I'm finished of my other equation, but it's probably a good idea to hang on to it if you're doing an IB assessment. And here's our regression equation where the slope is 6.93 and the y-intercept is 8.81, and our Pearson correlation coefficient to 3 sig figs is 0.997. Okay, I'm just finishing typing in that information here, those answers, and to 3 sig figs, of course. We got 3 down, and now to pull off 100 on this assessment would have been pretty tricky, because this is a kind of a sneaky question. You might think they're just asking you to input 750, right? Because of course that fits in. Sorry, I make sure I should look at the correct x value, the x values here. And then if you look at those x values, you'll realize I actually am not supposed to put in 750. I can only put x values between 16 and 115. So hopefully that got you suspicious. And you might actually be thinking this is a trick question. You might have just said, you know what, I'm going to extrapolate, and then we'll see what happens and just roll the dice, I guess. But you wouldn't have got the correct answer, because notice it's a total of 750 pieces. So really, kind of a real sneaky way of using your data. If I get my pen here and clear that stuff off from the previous question. If you look at your sums of pieces here, that's 89 and 16. So we'll say that's 105, which of course it is. That's the smallest sum. And up here we have 917 pieces. So if you add the edge pieces and the interior pieces together, the sums range from 105 up to 917. And of course, this is what they're actually asking you. Actually, I guess I'll shut that off since it's going to move along with me here. They want you to figure out at how many edge pieces she had found when she had sorted 750. So edge pieces is x. So figure out what was x when the sum of these pieces, turn that on again, when the sum of these pieces was 750. So how would you get an equation that represent the sum of the pieces? And if you think about it, it might be obvious now, just kind of how a lot of these IB questions are. You have to type in a second equation that's the sum of all these pieces is 750. It has nothing to do with your regression equation, but of course we need to figure out where this equation or this function, I guess we can write it as a function, y equals 750 minus x. Of course, you could input that as a relation on your TI Inspire as well, but where does this function intersect our regression equation? And of course, also keep in mind we want the x value because they're asking us for the number of edge pieces she had. So we have to pinpoint the x value at the point of intersection between either this function or that relation and the regression equation, which is approximately 6.93x plus 8.81. So let's go ahead and do that on our TI Inspire now as we wrap up. Okay, so here we are, and I'm just going to open up a graphing window, or at least attempt to. Now, of course, I have a couple of regression equations here. I probably should go up and see what I have. I don't want that first one. That was the last question, so let's turn this one on. And I think while I'm at it, I think I'll set up a scatter plot as well, which is a good idea. You don't really need it, but it doesn't hurt. And that's where our edge was x, and what did I call it? Interior. I can just type it in, but you'd probably be better off using your variables feature there. There's my scatter plot, and I'll do a zoom fit to the data. And now I can see, okay, that seems to be the correct regression equation with that scatter plot. And the last thing I got to type in is the relation x plus y equals 750. Okay, and of course I also could have typed that in as y equals 750 minus x, but that's probably a little more intuitive. And now we can find the point of intersection. I think using the geometry feature will work, especially if you type that in as a relation. So intersection points on that relation and that function. And we can see that if I hit escape, that the x value, which is the edge pieces, rounded to 3 sig figs, would be 93.5. Okay, and before we type in our answer here, I think it's important, and I did check the mark schemes to make sure. This rounding is sometimes a concern. IB doesn't have listed 93.5 in their mark scheme for a 3 sig fig answer here, although I would be surprised if they wouldn't accept that as full marks. They want you to round that to the nearest integer, which the correct answer would be 93, since that doesn't quite round up to 94, obviously, but surprisingly, 94 is also an acceptable answer in the mark scheme. So the mark schemes are sometimes a little bit vague here, but I think it's important probably to round this to an integer, because if you're talking puzzle pieces, you know, saying you got a half of a puzzle piece probably doesn't make a lot of sense. So go with 93. I'm not sure what the reasoning would be for 94 to be a correct answer. I guess you got more than 93 pieces, so I guess you're on your way to that 94th piece. So anyway, they'll accept either integer, either the correctly rounded one or the one that actually pushes this up to 94 is your number of edge pieces when you have a total of 750.